and the slide deck for today. So let's get to it. The 3D scanning has many uses in the construction industry, from providing topographical maps, creating BIM models, volume calculations, asset management, and much more. So we are blessed to have with us today Charles P. Johnson Associates' very own Chris Guagliardo. And Chris will present today, and I'm going to ask Chris to come on, turn on his camera, come on to the screen here. Chris, welcome. We thank you for participating and for putting on this webinar. Actually, you know, you were mentioning how much 3D scanning is actually being used in the construction industry. So I think this is a timely webinar, and I appreciate the fact that you put this together for us. So I'm going to turn it over to you and let you go ahead. And like I said to everybody, if you do have questions, please put them in the Q&A box or in the chat box, and we will take them at the end of the presentation. So Chris, take it away.
Great, awesome. Thanks so much for being here. I'm going to go ahead and start sharing my screen here for you guys. Once again, thank you all for coming to the webinar. And here we go. So once again, I am Chris Guagliardo. I am from Charles P. Johnson Associates. We're in the greater Virginia, Maryland, DC area, Delaware. So I've come to CPJ from Trimble and Keystone, which was a Trimble vendor, and I worked for them for about 3 to 4 years, doing all the scanning and all the training. So I am I am a certified Trimble trainer. So I know all the things Trimble and how to get those processes out. I also, before I was that, I've been serving since high school. I learned in drafting class, and then from there, realty engineering, and I've been doing this I'm 43 years old in August, so I got many years, but about 21, 22 years into this. 3D scanning, I'll take you through this. It's going to be a nice introduction on this, kind of showing you the different aspects that you can do with it. So there's many different things you can do with scanning out there. And the way these robotic transits are being produced, so now you can also have a total station, if you guys are used to that, that also scans. So if you have crews that are out there shooting topo or anything else, and you're afraid they missed something, you can just have them do a scan at the same time, and you just pick up extra data. So once again, I'll go slow through this, and please, if you have any questions, just put those down in the box, and if I cannot address them, all of them today, I will personally email you and get to those questions. So thanks again for the opportunity to show you guys this, and here we go. So my learning objectives for you guys today would be, how can 3D laser scanning save you money and time? And let you know if 3D scanning is right for you and if it's beneficial, and it's kind of right tool for right job. We have this. So, you know, you don't want to take a topographic scanner and go inside of a building and try to model with it. It's not going to give you the same production. And I'll get into those later on, letting you know what the difference is between those types of scanners, and then you can make your right decision on that. So a lot of you guys that are on here will understand that some things need to be, you know, a millimeter, and then some things you have, you know, 5/10 to a couple inches of tolerance. So this is where you would know that. So right tool for the right job. Again, there's 3 different types of scanners or methods that they use here. They have an infrared scanner that basically just sends out light, and it's just looking for distortion, and it picks it back off of determining, you know, what the source is there, how high the read is. So basically what I just took here is like a city here. So the blue buildings are harder, so they'll show up in the return a lot harder, and then the reds will be a little bit lighter, depending on how it's set up there, okay? Photogrammetry, basically, you can take 3 frames per second with a camera, and you can produce a point cloud out of it. So what this is doing is it takes your camera rating and bumps it up. So this was done with a high-grade LiDAR. When you're seeing that, planes fly over, they're taking, you know, thousands of pictures a second, so you can produce a scan from that, a little bit pixelated from there. LiDAR is basically, I call it like a sonar for the sky. It's just throwing down points, millions of points a second, and it's just taking bounces back. With that, you have a lot of interference in, so you have to have a good software to cut all that interference out. And they are the basic types there. LiDAR. So it's basically explaining LiDAR works the same way as like with radar. So this scan here was done with a modeling grade scanner because they were trying to figure out where the lines on this boat were coming in at here. And you could also from that model that boat. So you could take in there all the points. You could probably print that boat if you wanted to, or you could just sit down there and get parts out if you needed to. That would be more of a LiDAR grade. Same with the LiDAR 3D scanners. Here, you see a little bit, I think this is, might be, I can't remember what town this is. But basically, this is showing an overview of your LiDAR doing an entire city and how quick and fast. Now, this one here probably took them all together to get all this data done, probably if with flying over, it took them about 2 to 3 hours. Now, I know this one was done 2 different ways. They also mobile mapped it. So a mobile mapper is you put them on the back of a car or a truck. They're running on the, they're a little bit high power, more high power than the Google Maps and the other cars you see on there. They're producing about 2 million points a second, which I know doesn't really make sense to a lot of people. They go, why do you need that many points? Well, when you're driving around, you're just collecting lots of data. That way, when you get back in, you can sort through the data and cut down now. So this whole little job here, like with a mobile mapper and a LiDAR, you'd be done this entire little area in a day. Where think about traditional surveying, you know, you'd be stuck in that mall area up there in the Capitol for, you know, just trying to get all the mall and the museums, just get those outside. You'd probably be in that whole area for a week. This is done in a day. So self-driving vehicles will get that done. That helps them out there. And then the robotics of the lasers. A couple case studies here when they're doing LiDAR down there opposed to doing the imagery is that they got a lot more of the natural forest and they're trying to look what damage was done by the King's Fire. So instead of them just going through and taking pictures, they were doing a LiDAR. So they gave them a lot more profile on the ground and they could get a little bit more of where the actual burn was, because sometimes that the actual photographs on there won't, it's a little bit more pixelated, if you guys understand what I'm saying there. So you can't actually see where the burn marks were at in the jungle canopy. With the LiDAR, it penetrates a little bit more and you can actually see where those marks are. And then with the photo in there, it enhances the LiDAR. Who is CPJ? CPJ is an employee firm. I've been around them for a while. That's why I chose this company to come work for. They're great people. Probably one of the greatest companies I ever worked for. Very nice for everything. We're only under 100 people in the company. I have a couple people in my division. I'm the section head of 3D data capture, which is directly under Steve Jones in the survey side. So that's my boss. What do we offer? Civil engineering, environmental engineering, planning, landscape architect, and then where I take over in, they do the surveying, I do all the 3D data capture, the bathymetric surveys, and the LiDAR. So land, air, and sea is my saying at CPJ. We capture all reality, all 3D data capture. So if you have any ponds, rivers, we just did the Octoquan Reservoir. Yesterday I was out doing the Port of Annapolis for a dredge operation. We use the same technology. We use a scanner underneath it. It's basically a sonar scanner. So that way we get a 3D profile of what you have. At the same time, we run dual frequency sonar. So we're getting you top and bottom of silt. So along with the profile, you get top and bottom of silt, which is very valuable to dredgers and also very valuable to marinas, because that way when you're doing it, you give them a whole profile, a whole topographic map of the bottom, what they have. So if they have any point bars or anything that get in the way of the boats or anything, we get all that encompassed in there. So just those couple of parts I'm very, very keen to. I love being on the water. I also like scanning, so kind of perfectly fit there. So we're always busy out doing something. So not limited. We don't have any limitations, I should say. We can do anything. So here is a couple of our survey guns that we're using out there in survey. We're getting a little bit newer in there. So kind of up the top there, see if my mouse will work here. This here is an older Trimble, which they just stopped making here in the last couple of years. That's a TSC3 data collector. That's where your data is held in. So while you're out shooting this, which the yellow one here is a S5 Trimble, that is collected back to the data collector while you're shooting your data. The one below the TSC3 is an R10 receiver, and below that's an R8. The R10s are high quality. The R12 just came out last year. So we're using the highest quality GPS equipment that we can provide to you and ourselves. So that way we know all our data is correct. The one in the middle down there is a TSC7. The TSC7 is basically a laptop with a data collector in it. Gives you a little bit more screen time there, so you can actually see what a DTM, or you can see your actual topo a lot better in there, because a lot of guys have gotten older and they can't see, and I know I am probably one of those people. And then lastly, we have a mapping grade GPS there. Just if you want mapping grade stuff, wetlands or anything you want mapping grade, we can go out and give you that grade as well. So covering that. One of the projects we were doing down in the museum, they just wanted us to just do direct reflect of where all the little paintings were up there. So we basically just set the gun up in there and then shot all corners and turned that over to them. So construction, we're in there with you if you're doing anything in the interior now. I prefer, if I can see it, I would rather scan it, because I have all the points instead of just taking a couple with a robot. A robot's gonna, you can get 100 points in a robot. It's probably going to take a half hour to 45 minutes to get all those points, opposed to me sitting a scanner there and having it scan, and I'll have millions of points in 2 minutes. This is a laser scanner here, but this is a survey grade laser scanner. Okay, this one here is called the SX10. It runs to a tablet, either the T10 tablet, which is spaced there, or a TSC7. What this does is a lot different. So you still the same survey principle with this. Okay, so if you set your traverse up on station 1 and you put your gun on station 1 and you have your backside on station 2, you're going to use the same form. Then you can scan. While you're scanning with these, since it's held to a survey based, they register a lot different than you would with an actual terrestrial or model grade scanner. Since it works off the survey principle, it always registers itself. Backside 1 to 2. When you go to 2 and you backside 1, it recognizes where it's at. When you bring the scan in, there's no registry. Okay, and then what you see down the bottom, depending on what softwares you have or what you're using, what we use is Trimble Business Center, RealWorks, and an AutoCAD. Trimble Business Center down there automatically dictates what this has, and it has automatic recognition features. So the building is blue. You see a little bit of green on the building because of all the vegetation over there, so it transposed onto that building. And then you see the red as a tree. So it automatically identifies, so that way we can quickly go through. If you say, I just want all my buildings, I can quickly turn everything off in there and just look at the buildings and get you quick points in and out. Just breaking into some of the jobs that we were doing here. So this right here is a bathymetric survey. You should see the SX10. So what we did is we surveyed the top of the Potomac Dam. We did a bathymetric one there. And as you can see, there's holes coming through here. So they wanted to see how much water was still up there, but also at the same time, they wanted us to scan. Let me see, go back on there. They wanted us to scan up there. I do hope I have that slide in there. So we scanned the outside of that wall to dictate where any of the holes were, and then we sent that in very, very quick. This is the profile from what we got on the sonar out there of how deep it was at that spot. Okay, so that's how quick we can produce a little sonar map out of there and give you a complete data really quick with our sonar equipment. That's the scan. So you can see in the dam head, it has all those holes in there. So what you're able to do with the scanner was just go through and quickly scan it, and it was safe, because how are you going to get up there? Well, you could get up there with a robot from here and you could shoot it with direct reflect, but it would probably not give you the information you would need. So safety, we had to set up here, because up near the dam up there is about 5 feet of water. you'd have had to get the boat up there, which isn't really that safe because you have trees coming over the dam. So scanned all this, got all the holes in there. Everyone was safe away from there. And that was about a day's worth of work out there, which just probably trucking up there could have took you a day with all the rest of the equipment. So a day's worth of work with the scanner compared to you being out there a week trying to get this done traditionally. So where do you save your time and money at? Well, you save your time by not killing your guys in the field. You're also very safe because you're not putting them in any danger. And then also with everything that's going on right now with the coronavirus, you don't have to have as many people working together because you have that scanner. So one-man crew can get a lot more done instead of having a two-man crew and entering the heightens of the dangers that we have going on right now, which we just have to get through the pandemic here and we'll all be good. So I'm getting a little more into a modeling grade scanner here. So power substations and any kind of electrical or pretty much anything that's real high grade that they need really tight stuff, you're going to want a modeling grade scanner. If you look up on here in the measurements, the measurements up here are telling you what these wires are. So what my software does, and I've written in there, is that it'll automatically go through and dictate the size of the pipes, the wires, and the conduit. So on this one here, you see that the one pipe up there is about 7/100 of an inch, right? The next one's 1/10 of an inch. The next one is 7/100 of an inch. Excuse me, 7/10. Sorry. They need 3 millimeter accuracy on all this. That's their tolerance. So you cannot use a survey gun that's going to give you basically half a hundredth or whatever. You need tight stuff in there. So knowing the difference for this, okay. Same thing, pulls everything out, highlights anything that's power or has power going to it is yellow. That's how I have it in the software. That's how we make things a lot quicker for us and pass that on to you. So as you can see on the side over here, it has power lines. All my regions are over there, and also tells you the distance, stored measurements, and what we're looking at in there. So get into the mobile scanners too as well. They're modeling grade as well, and if you can look at this is the Bay Bridge. The Bay Bridge in Maryland is, I guess, for actually everyone over here, because you all got to come across if you come to Ocean City. And last year, while they were having problems, and before I worked at CPJ and they wanted to do the construction, they were trying to find a reasonable and quick way to, no, I shouldn't say quick. You can't really shut the bridge down. Every time we shut the bridge down, there's a bunch of delays, you lose money, and time is money. So they asked, how can we get a nice scan of this area without flying, because we need to be close down. And I proposed them while we were at Keystone is that we set some control points on either side, hit those with the mobile scanner as we go across. And so we put 8 control points. We put 2 on either side coming across the eastbound. There was 2 when you got across onto the eastern shore. There was 2 on the other side going west, and then there was 2 coming across. So we painted those up, and we made sure when we went across that we scanned those, came all the way across the bridge, went back across and scanned those. To survey a bridge or to survey any of that, it would take you quite a long time. To tell you that I drove across this and it only took me about it's 4.5 miles, about 20 minutes total to scan the entire bridge, and had everything they needed, all the decking, all the work on there. I had one person with me, so I had 2 guys. One was watching the scan while we're driving, because you can't watch the scan and drive at the same time, because it's just not safe. This would have traditionally taken, you would have had to close a lane. You'd have had to have traffic control. You probably would have only been able to do 1 lane at a time. and I'm pretty sure that the DOT would only let you be out there from probably 8 to 3, whenever the lower traffic time is. And here your day would probably be shut to 4 hours. So you would take probably a week just to get across one side of that. So you figure I did it in less than an hour. It really saved a lot of time, and it was very safe doing that as well. So that's another benefit of these scanners and these mobile scanners, is that it's safe. And you have to just make sure when you're doing a model grade or these scanners that you tie it into survey control, which is very easy. So there's the actual picture that's on the camera when you're going through scanning. These are not here no more. If you guys have been over here, the easy pass lanes are gone. They took all the tolls out now. You just drive through and you get scanned when you get across on my side of the bridge. So this is all gone. But from here, from this photo, you can draw pictures. You can do anything. You can pick points on it, because in this picture, the point cloud's behind it. So when you're asking, are you actually picking the right point? You have a photo to pick from, you have a scan to pick from, and then you can have an actual point that you can make in there and pick all your different distances on there. This was just a regular scanner inside of a storm drain. So I'm kind of popping around, just giving you a bunch of different things that you can use these for. So what I needed to do here is I needed to see what was going on inside this pipe, if there was blockage or anything else, because we were putting in a new, this is down in PG County. They're doing another stormwater management pond down there, and they're having problems in this. So I just, instead of me going down and shooting it, I put a point down inside the manhole, or the box riser there, and we scanned it. Now from here, you can do many different things off of this, but I got a whole profile, a whole slope profile going through that pipe, so you can see anything that was going on. It was fine. It ended up being a clog at the end, no big deal. But at the same time, I can create a BIM model out of that from what I just got there. So that right there is what that concrete structure looks like. Slope on the top is the same, because that's how they have the yard inlet or the trash, or where it relieves out top. I can't remember the actual name of it. I'm sorry. Trash rack, something like that. But from there, you can model that in BIM, and then you can go ahead and take it over to Revit, or you can go ahead and basically make that model and make a DWG, and they can print that out. And they're doing lots of different things. Same thing as you can go ahead and pick out in SketchUp or in Revit what you want to make in there. So you can make it look like whatever you want. ADA compliant, scanning ADA. This whole job here was I don't know, about 3 acres. Did it in about 30 minutes, and all this was done. So what you do is you go out and you scan it, and then from the scan you acquire points. You make points in there where you'd like them at. So basically they were looking from the sidewalk to the edge of curb, and then out into the parking spots, because they got to make it ADA compliant. So really quick, went in and surveyed it, got all the graphs in there, it made a surface, and then you can keep going through. And basically what it's showing you is the wood line, and gives you a nice slope coming all the way through very quick. So now you know if you're ADA compliant and what's going on. So if you're at, excuse me again, if you're as built in it, you have a really quick slope profile, real quick. And if you're just doing an overall out there from just seeing what you got, that's how quick you got it. It literally does not take any time to get those profiles out because of the scan. So you don't have to worry about having your surveyor go out there and grab the right points. You have all the points already there. Playgrounds. One of the things that we do around here is, we like to look for different areas to put playgrounds. We've been doing a lot more in Queen Anne's County. So if there's a playground that someone really likes, or really likes how it's laid out, we can scan it, and then I can go out and scan your area, and I can take that 3D model and put it in that area, so that way you can see what you could get. We can do that with anything too. I can scan the house, anything like that, and we can sit it in there. It's just trying to give you ideas of what you can use this for. So this is what I did with the playground here, is that we have a pavilion on the bay. They had nothing up there. It's just a flat basically slope up there, and they wanted to put things on here. So the only thing that's actually up here is that little corner building up there, the bathrooms. Everything else was not there, flagpole, stuff like that. So what I did is just made 3D models of everything and just put them in where they needed to go. The little road striping there is where we were going to put a parking lot at. So just really, it's nice. You can take this on here. You can show a client, you can show a customer what they can have, gives them kind of idea, because a lot of people just want to see what I can actually get. And this is actually showing. Oh, I'm not ready for that yet. Same things in there. I'll get more into the 3D because I thought I had a little bit more slides there, but I was talking a little fast. With this 3D scanning, so for your interior buildings, you basically just set it up in a room and you can scan it. Now, depending on how you want to get measurements out of it, so say you're scanning a 2-story house inside, you can set up prisms, or you can set up what they call spheres. They're like a little, you see in a little white spheres. I tend to make marks or just do different things in the house so I can register it. Look for different parts of the house to register it in there and make them tight. But like I said, you can use targets. So if I was doing my house here, I would scan one room, go right to the next scan, and keep going around. While I'm doing that in there, it's going to register when I get done, and then I can start making measurements in my house. Wall length, anything in there, very quick. For people who don't know how to use the scanner, while it's doing that, it's taking a picture. And like I said, you can draw off the picture completely. So you can make all your root measurements in the picture. You can do everything off that photo as long as the point cloud's behind it. It might be too much information, but too much information is way better than less information. Other things about the scanning is when I was getting into the modeling grade and the survey grade in there. A survey grade scanner is going to have a data collector with it because it's still putting that data into a collector. That way it's collected and you don't have to worry about it. The difference with the modeling grade scanner is you're going to have a memory stick or a nice big hard, or what do they call those things, little plugins. But usually one that's got about 64 gigs or more, because most of the scans that if you're doing there, you're going to put a lot of damage on it. It's usually about 20 gigs per scan if you're doing any more than 5 setups on there. So that's when you need to have a card. It does not have an internal memory on it. It just scans. That's all it'll do. So you basically set it up and you have different settings to put on there. So you can tell the scanner that I want you to scan, every point within 100 feet at 1/100th of an inch, and it'll do it. Anything closer than that 100 feet will be closer than 1/100th of an inch. So if you look at parameters, and the parameter says at 200 feet, you're at 1/1000th of an inch. Everything closer than that is denser. So you have to realize that you're only making that thousandths of an inch out that far. Everything inside is a lot closer than what they got going on there. It's very close on that stuff. Then the survey grade will not do the same stuff as a modeling grade. So if you get in a problem to where you're trying to get a scan done with a survey grade scanner out there and you need modeling grade, just get someone else to do the modeling grade for you, because it's going to take you a lot longer and you're not going to be satisfied with the quality that you get out of that survey grade scanner because of how you have to set it up. Setting those up, I've got them to do 1/1000th of an inch, but 25 minutes to take a scan to where I can set the other one up and have the same thing done in 3 minutes. You're trying to save time, because usually when you're out there doing a scan, you're limited to sight distance, and everybody knows there's lots of people moving and in and out. So the quicker you can get a scan done, the less likelihood you have someone blocking your images on there. Let's see, I'm trying to see if I haven't covered anything else in here. Let's see, I just want to make sure that you do know there is 2 different scanners. Make sure if you're in construction, you're probably going to need a modeling grade scanner unless you're doing stakeout or topographic work. Then you can just get away with the survey one. But if you're doing construction, BIM modeling, or any of that stuff, you're going to need a modeling grade scanner. I'm partial to Trimble just because that's what I've used, and just getting to know that product. I would say that you don't have to worry. Like Leicas are very good. Ferros are very good. I'm sorry, I have a bug flying around me. I can't stand them. But you want to make sure the specs are what you need. There's a phaser scanner and there's time of flight. Basically, a phaser scanner just puts out waves of, and it just will just distort. So if it hits, say, my hand right here, everything back there, it fans out wider. A time of flight scanner just keeps scanning up here. So only thing it would miss out would be my hand. If there's anything over here on the other side, it's going to get that. So knowing that, then right tool, right job. There's also free, if you look up GeoSlam, there's handheld scanners now. What I found out about those is that if you're not within about 10 to 20 feet of it, you're not getting good results. So it would work really good for tight spaces. Like if you want to get down in a manhole, or say you had a overhanging ceiling where you need to get up there and see where the pipes are at, that would work very good. But if you were going to walk down the street and try to scan the front of a house, not so much. So right tool, right job. I know Leica makes the RTC 360. That's kind of like the SX10. I hear good things about that. I also hear that the DLKs are pretty good. But again, right tool, right job. If any of you that are thinking of going that way of scanning and need some guidance, my email's here. I'm more than free to reach out to me about that. There's lots of new things in there, but I say this right now: if you're not scanning within the next couple of years, you're not going to be getting any quality, and you're going to get a little bit left behind. And I've been seeing that since I was on the inside, is that a lot of big trends are moving to scanning. A couple of the companies before I left there were buying it, doing stuff at Merit Property. So when they go out and do their asset management on a property, they send a guy out to scan and it gets photos. So they have a very, very quick asset inventory of what's out there. Okay, I can see this. I have this. I have many parking spots. The building looks like this. It's very quick. You can do the building that used to be down in Keystone was 10 setups to get around the entire thing. 10 setups ended up being about 4 million points of setup, and we were done that in an hour and a half. And then you could just go through and pick points, and we could just give the photo. So again, very fast, saves you time, saves you energy, saves you people. The only thing it's really not probably going to save you time on, which no one really wants to hear, because everybody goes, well, we're making up time somewhere. We got to be losing time somewhere. Well, you're not really making up time in the office, because you still got to do your CAD procedures and the stuff you need to do there. I mean, you can't speed that stuff up. By picking the points and making a surface and doing all that, you can do that pretty quick with this. The only thing I said is that when you're actually doing your designs, it's still the same old tried and true CAD way. I do hope I've addressed everything on here. If there's anything that I'm not covering in there, please put it in the chat box and I can get to that. But I just want you to know, thank you for your time. If you do choose to use CPJ, just know that your data is in good hands. We are very, very knowledgeable. I did not know that my boss was at the company for 35 years, and that's something very rare you see now. So a lot of these guys have been in this company for a very long time. We do a lot of teaching with the Maryland Survey Society. I just finished doing classes with those guys and teaching in there. So we have a very knowledgeable staff of engineers and surveyors, and I'm just happy to be here and offer them this 3D technology. And Mark, I can answer questions if we have any up there.
Okay, thank you so much. I appreciate that. And I wish I understood about half of what you said.
I try to keep it. I probably get a little too technical, but that's just what I do. I'm sure some people on the webinar know, but if they don't, like I said, I'm more than willing to answer all questions. So.
No, I appreciate it. And so let me ask you this. I just had some remodeling done in my house, and Would you strongly recommend, and maybe this is a softball bet, using a company that has this type of technology, even in the remodeling world, so they can get it right? Because I'm very pleased with what happened, and I believe they used a similar technology.
Yes, because you're getting all that information, Mark. So if you get in your house and you're like, you know what, I didn't like how the window came to the door. How far is this in here? So you get so many more different things in there that you can actually see off of it. So the scanning is a lot quicker. You mean you go out, me and you go out, we take a measurement, right? And I say, yeah, it's 3 3/4 or whatever, and you just write the wrong number. So now we've lost that measurement, and we go and make the cut. We thought we come out here, it's wrong. Well, now we have all those measurements done digitally, and they're just there available even though you don't want them. So yes, that is a very, very, very good use for that.
So is there ever a downside to using this technology?
Sight distance. So say we were in like all that scaffolding that was up in that building up
Right.
there, it limits to where I can actually see because it's in front. So the best thing to do, like when we do a museum or anything else, I ask them to, can I get in there before there's any scaffolding? So that way I have nice sight on everything, have a nice clean picture, and then get out of there. And then whatever they want, I can pull the measurements out.
Okay, good. Well, that's good to know. So I don't have any questions or chats, which means you must have done an excellent job presenting your material. And the people here on this call, the audience obviously knows this subject matter very well. So, but I appreciate you putting this presentation together for NVBIA and presenting it to our members. I think it's a value to our members to have somebody like you and your company available to them anytime to help them out with their building and construction needs. So thanks so much, Chris. As I mentioned before, we have recorded this. We'll be sending it out along with Chris's slide deck and a survey. If you have any questions, you saw Chris left his information up on the screen, but we'll send that out to you as well so Chris can talk to you directly about any questions you might have. So Chris, again, thank you very much, and I wish everybody a good day.
Yeah, thank you guys so much.
Okay, take care.
Yep, bye.